Hey everyone, this is our lesson on stoichiometry. And by the end of this lesson, you should be able to analyze the stoichiometric relationships inherent in a chemical reaction. But you may want to pause the video now and review mole conversions before you start. So stoichiometry is basically taking our last two major concepts of moles and balanced equations and putting them together. So before you start a problem, you have to make sure to have a balanced chemical equation. In a lot of cases, I'll give that to you, or if I want it as a review problem, I'll give you like the skeleton equation you'll have to balance before you can do the stoichiometry. Remember that mole ratios are comparing moles of different substances, and to do that, you actually use your coefficients, which is why you have to have that balanced chemical equation. So if you use this example over to the side, for every 2 moles, so let me kind of write on this, for every 2 moles of H2O, you need 1 mole of O2 to react. So you would write that as 2 moles H2O2, I said H2O2, for every 1 mole of O2. That's their ratio at which they react. So for a balanced chemical equation of the formation of ammonia here, an example of a mole ratio, just one of them, an example of 1 mole ratio here would be 1 mole of N2 for every 3 moles of H2. So you can actually write a mole ratio for every reactant or product in the formula, in the equation. So another one here, so you could look at this in relation. For every 1 mole of N2, you will be able to form 2 moles of NH3. Okay, so just look at those as a comparison. It doesn't have to be just reactants or just products. It can be a little bit of each. So this, I'm going to X out. Well, let me just shrink that. There we go. So look at this picture here. Pause the video and copy down. You don't have to copy down all of this stuff, but just your basic mole pathway here. So we see... and I'm going to kind of circle the stuff you really need to know in terms of the arrows. So everything that's in the boxes you will want to copy down. But for the arrows, you'll want to copy down these little conversions that we have here. And for the middle, you're going to use your balanced equation coefficients. And then you're going to use what I've circled there. So if you want to pause now that I've circled those, you can go in and write those. So once you come back after you've written these down, just a couple things to make sure you understand. Remember, when we walk through these examples together, I will keep saying the same things that we did with mole conversions, as in, I'm comparing mole to a different unit. How many moles do I have? For every 1 mole, how many representative particles is that? For every 1 mole of any gas at STP, that's how many liters. I'm going to keep saying those same phrases so you will hear them in your head when you're doing these problems by yourself. But one thing that we'll point out here is when we're going mole to mole, and you will hear me and it will get on your nerves. I know that. But I'll say, uh-oh, I'm mole over mole. Where do my values come from? And they are coefficients on the balanced equation. This is the only time this area in the middle, going from moles of what you start with to moles of what you want, this is the only time that it will not always be 1 mole. Okay? When you're comparing mole to a different unit, it's always 1. But when you're comparing mole to mole, it could actually be a different value. So I'm going to set this one up and work through it, and then you will have an example problem to try. And I suggest, again, underlining what you're given, circle what you're looking for, just so you don't get lost, and writing out your pathway to the side. So we have how many liters of O2, so that's what we're looking for, at STP, which we know we're at STP, will react, let's say, with 8.7 grams of C2H4 to form CO2 and H2O. And I would suggest, okay, this CO2 and H2O, if that's going to confuse you, you need to scribble that out, because we're only dealing with the one that we're given an amount for and what we're looking for. Okay. So now let's look at what our pathway is. So our pathway here, and I'm going to write it to the side in case it pops up. I can't remember if I typed it in or not. As you can tell, we are going from grams of C2H4. Well, I can't go all the way to liters of O2 straight. I have to go through moles. Remember, anytime we change from one type of unit to another, we got to go through moles. Well, to get from grams of C2H4, the only place next we can go is moles of C2H4. Once you're in moles of that, then you can go to moles of O2, and then from there you can go to liters of O2. I didn't think I typed it in. All right, so just ignore this question for now. You'll come back to it in a second. So now let's work this out. Let's set it up the way that we need to, and we'll work it out. Here's my calculator. Okay. So when we work this out, we could tell from our starting point, okay, that we are looking at grams of, you're not really going to see me for a second because I have to kind of tip this to right, so I might as well cut my camera off. So you're going to go from our grams that were given, which is 8.7 grams of C2H4. We're going to get rid of those so they go on the bottom. And this is why when we did moles, I told you to practice writing out all of your units and your compounds. So don't just write out the unit. You want to write out the compound as well. So based on our pathway, we're going from grams of C2H4 to moles of C2H4. I'm comparing mole to a different unit, so that means I always have 1. Okay, and then to find out the mass in 1 mole, you just add them up from the periodic table, and I'm going to kind of, simplify it here and just put that at 28 grams. As you can see here, the only thing that can cancel are the units of grams of C2H4. Well, now we're in moles of C2H4, which hasn't canceled. We need to go from those to moles of O2 based on our pathway. So they go on the bottom. Moles of O2 go up top. And I'm mole over mole. My numbers come from the balanced equation. So I've got 3 moles of O2 and only 1 mole of C2H4 because there's no coefficient out front. So we're going to, I should put that in purple. So we're going to put a 1 there and a 3 here. Well, now we can cancel out this whole section of 1 mole C2H4. And from here, now we need to get rid of moles of O2 and go all the way to liters of O2. I'm comparing mole to another unit, so I always have 1. And 1 mole of any gas at STP, if you remember, is 22.4. I can go in and cancel my moles of O2. I'm left with a unit of liters of O2, which is what I want based on my pathway, so that's great. So now you just do the math. So you're going to take all these numbers on the top and you're going to multiply them all together. And then you're going to divide them by 28 because you have 1s on the bottom, so they don't do anything. So 8.7 times 3 times 22.4 is going to be, I'm going to just write this to the side over here, 584.64 over 28. Oh, sorry. I don't know why that line just shot across my screen. 28. So you're going to come out to around 20.9 liters of O2. And when you write these out, you have to put the unit and the compound that you're dealing with. So now, guys, that I've worked that out, I know it took a minute, but now that I've worked that out, pause the video because I'm about to clear my screen. If you want to write all this out, pause it. And I want you to go ahead and try the example here at the bottom. So pause the video, try that.